So, let's talk about polynomial division. I didn't mean to sound so excited there, but you know, it's kind of cool. So let's start with a quote, simple example. Now, if we want to divide the expression 3x to the fourth minus 2x squared minus 1, all divided by 3x cubed, when we have a single term in the denominator, it's called a monomial. We can, I gotta change this thickness here, that's too much. I think that might be too much too, there we go. We can rewrite it. So this denominator goes with every single term in the numerator. All right. So if it's a single denominator, we could just divvy it up, right? Just like taking the opposite of finding the common denominator. And now we'll simplify. So the 3's cancel. X to the fourth, x to the third. We have more x's in the numerator. Minus sign, 2/3. X squared and x cubed. We have one more x and it's in the denominator. And nothing to simplify here. And we've divided. It's not very helpful, but we've divided. There's a quotient right here, and this will happen to be our remainder. Any part in fraction is our remainder. Any part without the fraction, without the variable in a denominator, is going to be a quotient. Now, let's do a quick reminder here. If I wanted to put 3 into 14, right? This is 14 divided by 3. That's 14 divided by 3, which equals 3 going into 14, and I don't like where that is, so I got to fix that. It was just way too packed. There we go. 3 goes into 14. So we ask ourselves, what do I multiply by 3 to get close to 14? That's going to be a 4. We multiply, we subtract, and we bring it down. All right, this is called our quotient. This is called our remainder. Let's look at what's called the division algorithm. Let f of x and d of x be two polynomials with the degree of d of x greater than 0 and less than the degree of f of x. All right, so like 3 is smaller than 14, but 3 is not 0. Then there exist unique polynomials q of x and r of x, such that we could write f of x as the divisor times the quotient plus the remainder, where either the remainder is 0 or the degree of r of x is less than the degree of d of x. All right, so if you're dividing by a linear term, or actually, let's look here, 3x to the third. If we're dividing by an x to the third, our remainder has to be x squared or less. All right, and less being in the denominator. Okay, terminology, here we go. Let's divide. Divide the first polynomial by the second. So we will have x to the third minus 2x squared minus 5x plus 6. And we will divide that by x minus 3. So I ask myself, what do I multiply x by to get x cubed? Well, that's going to be x squared. So let's multiply it. X squared times x is x cubed. X squared times a minus 3 is a minus 3x squared. Right, just like we multiplied 3 times 4 and got 12. Now we're going to subtract it. And when we subtract x cubed minus x cubed, they go away. That's our whole goal. Minus 2x squared minus a negative. So we're going to change that to a positive. There we go. That is an x squared. And we'll bring down our minus 5x. And then we play the game again. What do I multiply x by to get x squared? I multiply it by a positive x. Positive x times x is x squared. Positive x times a minus 3 is a minus 3x. We subtract it. As we subtract x squared minus x squared, nothing happens, right? They cancel out. But if we have a minus 5x minus a negative, I should put a minus sign in there. This will be just a little darker there. A minus 5 and a positive 3 gives us a negative 2x. And we'll bring down our 6. And I ask myself, all right, what do I gotta find another color here. Let's go orange. What do I multiply x by to get a negative 2x? That's going to be negative 2. So I multiply negative 2x. Negative 2 times a negative 3 is a positive 6. We'll subtract. But remember, when we're taking negative 2x minus a negative 2x, they'll cancel. And 6 minus 6, that's 0. So we have our quotient. Our quotient is x squared plus x minus 2, and our remainder happens to be 0. So basically, x minus 3 times x squared plus x minus 2 equal x cubed minus 2x squared minus 5x plus 6. No remainders. It goes in nicely. Now, I did change this problem right here. I'm going to have to erase that now, but just so you know, if you're looking on the notes that I have posted to the class, I changed this problem because I kept getting 0 remainders and I was bored by that. All right, let's try this again. And this time we're not going to do the separated colors. Here we go. All right, so we're dividing. So we have 3x cubed minus 10x squared. Let's make it look like an x. Minus 27x plus 10. Let's divide that all by x plus 1. So, what do I multiply x by to get 3x cubed? That'll be a 3x squared. When I multiply, I get 3x cubed plus 3x squared. I want to subtract that. Subtraction changes our signs. So we'll have 3x cubed minus 3x cubed, a minus 10x squared minus 3x squared, so that's a minus 13x squared, minus 27x, oh my goodness. What do I multiply x by to get a minus 13x squared? How about a minus 13x? When I multiply, I'll get a minus 13x squared minus a 13x. That one's kind of handy, isn't it? Don't forget to subtract, right? Always subtract. And when we subtract, it changes the sign of everything in the parentheses. That's why I used the parentheses. 13x squareds cancel out. A negative 27x and a positive 13x is a negative 14x. Oh, I forgot to bring it down. I like to draw arrows so I know where I am because I am frequently off kilter, right? And I don't have lines, so I don't necessarily write it in a linear fashion. Negative 14 times x. Negative 14 times 1. We'll subtract this. Negative 14x minus a negative 14x. I might as well follow through, change my signs here. 14x's cancel out. 10 and 14 makes 24. So my quotient is a 3x squared minus 13x minus 14. And my remainder is 24. What that means is we could rewrite 3x cubed. Okay, so this is my answer. I'm done. I'm done with what the question asked, but just a little extended learning here. Our polynomial, according to the division algorithm, can be written as x plus 1 times 3x squared minus 13x minus 14 plus 24. All right, so this is our function. This is our divisor, our quotient, and our remainder. Notice our divisor was degree 1, so our remainder has to be a constant. Remainder has to be a constant there. So we could keep doing this, but look how messy that is, and look how many lines. 1, 2, 3, 4, 5, 6, 7, 8 lines at least. And so it takes up some room. Synthetic division is a way of taking out the variable, but you have to stay organized. All right, so what we're going to do is, first step, we are going to write our coefficients. 1x cubed, 2x squared, minus 17x, and a minus 10. All right, second step. We're going to take x plus 5, set it equal to 0 to get x equals negative 5. I'll explain more of that in a minute, probably a later video. Think factors and zeros. All right, and that's all we need for our setup. Now what we're going to do is obviously not draw a straight line. That's too much. We're going to bring this straight down. All right, so we're going to always add straight down, but to start us out, we just drop the 1. Now, to move up and over, we're going to multiply by negative 5. So negative 5 times 1 is negative 5. And then we add straight down. When we go straight down, we add. So we multiply by negative 5 to go up and over, and we always add straight down. Add straight down, multiply to go up and over. All right, I'm going to make this a little bit bolder so we can see it better. Negative 5, 1. So 2 and negative 5 is negative 3. Negative 3 times negative 5 is 15. Negative 17 plus 15 is a negative 2. Negative 2 times negative 5 is a negative 10. And if I add straight down, I get 0. Now check this out. Let's use a different colored pencil. Let's use a dark blue pencil. This is our remainder. And this part is our quotient. All right, our quotient can be written now as, I need more space over here. For problem number 1, our quotient. See how this was x cubed? This is x. X cubed divided by x will leave us 1x squared. And then they just follow down in order. That's a minus 2 with a remainder of 0. And you could do this by long division if you wanted to check the work, see how it works out. But it's pretty cool, actually. So we'll do that again. So we're going to start with x cubed. So we have 1x cubed. How many x squareds do we have? We have 0x squared. You have to add the 0. You have to have every place written down in synthetic division. So there's x cubed, x squared, x's, and my constant term. On the outside, x plus 4, I'm going to set it equal to 0, so I'll get negative 4. But this really can be done without such dramatic work over here. Bring down the 1. Negative 4 times 1 is negative 4. Add straight down. Multiply. Add straight down. Multiply. Oh, that's gross. Okay, so it's going to be negative. 4 times 10 is 40. 4 times 4 is 16. So 40 and 16 must be 56. A negative 56 and a positive 1 is a negative 55. Our quotient, right? We had x cubed. We decreased it by 1 power of x. So this is x squared minus 4x plus 14 with a remainder of negative 55. All right, so the remainder is not always 0. I do this in a lot of my examples because I accidentally pick some really nice polynomials sometimes. All right, let's do one more just so you can see that it doesn't always start with an x squared. I'm feeling blue. So we'll go 3x cubed minus 11x squared minus 20 and x plus 3. X minus 5, set that equal to 0, so we'll get x equals 5. Draw the line, here we go. Bring down the 3, it always drops. That first coefficient always drops. And then we multiply to go up and over. Add straight down, multiply to go up and over. Add straight down, multiply to go up and over. So my quotient is right here. let me see, we had x cubed, we decreased it by a single x, so we're at x squared. So this is now 3x squared plus 4x. And you could write the plus 0 if you want to. It's not necessary, but it's true. And our remainder is 3. All right, so here's this cool little fact. Oh, no, that's not the fact I was thinking of. We'll come about that in a different video. It's a fact I was thinking of, but didn't say out loud. So when we use synthetic division, we can also evaluate a function as well. So if a polynomial f of x is divided by x minus k, the remainder is f evaluated at k. Wait, what? Okay, so let's try this one way. So divided by x minus k, the remainder is f of k, right? So what are we subtracting? We're subtracting the 1. If I wanted to find f of 1, this would be 1 squared minus 3 times 1 plus 1. 1 squared is 1. Remember, square the 1 first and then multiply by 5. So I have 5 minus 3 is 2 plus 1 is 3. Now this says that if f of 1 is 3, then if I am dividing 5x squared minus 3x plus 1, x minus 1, set it equal to 0, x equals 1. This remainder theorem, this cool thing, claims that my remainder down here is going to be 3. Let's see. Bring down the 5. 5 times 1 is 5. Negative 3 and 5 makes 2. 1 times 2 is 2. 1 plus 2 is 3. Hey, look at that. The remainder is f of 1. And maybe that's just a cool thing with 1s, right? We're looking at negative 4. What's f of negative 4? Negative 4 times negative 4 squared plus 6 times negative 4 plus minus 7. All right. Negative squared makes positive. 16, right? So 16 times negative 4 is a negative 64. 6 times 4 is 24. So that's a negative 24 and a negative 7. That's a lot of negative. 64 and 24 makes 88, and another 7 makes a negative 95. And that was, it tickled my brain a bit, right? No calculator. We don't need no stinking calculator. Synthetic division. Negative 4x squared, 6x, a minus 7. Set x plus 4 equal to 0. That's why we use the minus 4 here. We use the minus 4 here. Bring down the negative 4 and we multiply. 16. 16 and 6 makes 22. I about got us way too big, way too fast. 22 times a negative 4 is a negative 88. My brain and my hand do not seem to be connected anymore. No, we had a 16, right? We had an 88. All of these numbers are sounding familiar because you do the same arithmetic, but you don't have to do it as in such a difficult way with synthetic division, right? You don't ever have to know that 4 cubed happens to be negative 64. You don't have to do, but I guess you still have to do arithmetic. But one way to evaluate a function is by synthetic division. All right, that's it for polynomial division. Thank you for listening.